Alright, I'm going to make a video going over all of the spring final exam problems. It's going to take quite a while, so you can always fast forward to particular ones that you need. So here I go. Okay, first question. This is actually divided between a cylinder and a cone. So this part here is the cylinder, and this part here would be the cone. So if you want to find the volume, you would just use the two different formulas. So cone has a good formula. That one is 1/3 times the area of the base. Now the area of the base is it's actually a circle, and it says that this cone, or this rocket, has a width of about 2. So that means that the radius would only be 1. So we're going to do pi r squared. The radius would be 1, so 1 squared. And then times the height. It said that this part was 4, and it said that this part was 20. Okay, and so that's the cone, and then we would add that with the volume of the cylinder. And the cylinder formula is area of the base times the height. The area of the base, again, is a circle, so it's pi and then 1 squared. And the height is 20 of that cylinder. So this here multiplies together, it's 4/3 pi. And these multiply together, so that's 20 pi. And if you add those together on your calculator, you can do that. So you would get 64/3 pi, or if you wanted to get a decimal, that is 67.02. And because that's volume, that's cubic feet. Okay, next problem, we have a triangle, because we have Michelle here, and she's standing near a 45-foot lighthouse. So this is the lighthouse here, and she looks up at it 36 degrees. So this would be 36. If it lets me write it. Alright. And then what we want to figure out is how far is she standing away, so that would be this distance. Of course, this is Michelle. Okay, so the relationship here is that from the angle it's opposite, and then this is adjacent, so that's a tangent relationship. So we would say tangent of the angle measure, which is 36 degrees, is equal to 45 over x. These problems, when the variable is on the bottom, I always do them in 2 steps. So I multiply by x first, and so then that's x tangent 36 degrees is equal to 45, and then I would divide by tangent 36, both sides. And so then x will be whatever you get on the calculator there. And it's about, let's see how much that is. So 45 divided by tangent 36. Yeah, it's like 61.9, or about 62. And that's feet. That's all, yeah. It says round to the nearest foot, so if we follow the directions, if I do, then I would say it's about 62 feet. So yeah, try to follow the directions there. So not, get rid of that, 61.9. Okay, next one. Okay, circumference and area of the circle. So circumference of a circle we know is 2 pi times the radius. So 2 pi times radius of 18.9. So circumference is about 118.8, and that's meters. And then we have area. Area is pi r squared. So area is pi times the radius, which is 18.9. We're going to square that. So area is about, let's see, that should be about 1122.2, and that's meters squared for area. Okay, volume of a cylinder. So volume is the area of the base times the height. The area of the base is a circle, so that's pi r squared times the height. And so this is pi. The radius is given, so it's right there, it's 5. So 5 squared times the 18. This one says give an exact answer, which means that they need to keep the pi in the answer, because otherwise we would have to, we'd have to round off the pi at some point, because it's irrational, it never ends. So we want to multiply the numbers together. So when you do that, you get 450 times pi, and that's because it's volume, it would be units cubed. It doesn't give feet or anything, so we just say units cubed. Volume of a cone, really similar. Its volume equals 1/3 of the area of the base times the height. Well, the area of the base is again a circle, so it's pi r squared and then times the height. So 1/3 pi, the radius here, the diameter is given, so we know the radius is 7. And then the height, this one actually is not given the height, so it's given the slant height. So we have to figure out the height. This would be 7, so if you do the Pythagorean theorem, so I'm just going to make a little note that you use Pythagorean theorem, because I know that you know how to use the Pythagorean theorem, and we will on several other problems. Use Pythagorean theorem to find height, and the height for this one is 24. It's also a special Pythagorean triple, 7, 24, 25, but you don't have to have that memorized. You can just figure out that it's 24. So now, exact answer again, we multiply all the numbers together and leave the pi, carry the pi along for the ride. So this would be 392 pi, and again, that's cubic units, whatever the units turn out to be. Okay, volume is 250 pi, so volume is 250 pi, and the diameter is 10, so radius would be 5. So if we use the volume of a cylinder, the volume of a cylinder is pi r squared times h. So if we do pi and we use that radius of 5, then we can do 5 squared. The only thing we don't know is the height, so we can just put that h in there. And then if it says diameter, I can divide by the base of 25 pi, so that's this part. So you can divide by 25 pi on both sides, 25 pi, and if you do that, you would get, this would all cancel out, of course, and then you would get h is equal to 10, and that's the first part. Actually, part A, it says what part of the cylinder is the algorithm finding, so you'd be finding the h. So that would be the height of the cylinder. And then what value is this? We would say h equals 10. Okay, when you have an inscribed, this is an inscribed quadrilateral. When you have an inscribed, let's see if I can spell inscribed, sorry. The opposite angles are supplementary. So these ones here are the ones we need to do first. And we would add them together and set it equal to 180. So we're going to set them equal to 180. So then we're gonna get 5x, and we're gonna have minus 15 equals 180. So don't mind my notation. I'm just gonna be solving for x to help us out here. So we got x equals, what do we got? 39. So if x equals 39, then we also can add the other ones together, these red ones. Let's add those together. So we get x plus 12 plus 3y equals 180. And now we know that 39 is x, so we can put that in there. So 39 plus 12 plus 3y equals 180. And then this would be, what, 51 plus 3y is equal to 180. 3y equals, and then we would subtract 51 from each side. So that would be 129. And then I'm running out of room because I don't want to pinch and squeeze this thing because it stops writing. So 129 divided by 3 would be 43. Number 8. So these polygons are similar, and so whenever they're similar polygons, you can compare the corresponding sides. So compare corresponding sides. So you can just find a couple sides that you know relate to each other. So you can do 10 over 2 and then try to find in a variable. So this one has a variable here, so then just compare the x plus 2, put that on the top so that it's the same, as the 10. So x plus 2 over the 3, and then you can cross multiply and solve for x. So when you do that, just make sure that you distribute the 2. So let's see what we got here. So when you have 2 parentheses, it'd be like this, just showing the work. Make sure you distribute that. So it'd be 2x plus 4 equals 30, and 2x equals 26, and x has to be 13. And then for the other one, the other variable, you can use the 10 over 2 again. So 10 is to 2 as 20 is to y minus 1. And then do the same thing, cross multiply. So this is 40, and then this distributing, I won't show all the work on this one, 10 distributing to the y minus 1 would be 10y minus 10. And so then 10y would equal, if we add the 10 over, that'd be 50. And so y equals 5. Okay, these two triangles are similar. It doesn't really say that they're similar, but they are similar. If you compare the side lengths, they're proportional. They turn out to be, they have a side angle side proportionality. So that means you can figure out this missing length. So compare a couple of the sides that are corresponding. So if we could do 39, this one here, over 42.9, and then we could say this side definitely corresponds to this side, so we'd say 38 is similar to, or relates to x, is the corresponding side with x. So then we can cross multiply. So when you do that, you would get 39x, and that would equal 1630.2, and then divide by 39, so you get 41.8. Okay, population density. So population density, you can figure out, how dense it is with people. So you take the number of people, and it's divided by the area. So you have to read the question carefully. So we're trying to figure out the population density of Pima County. So we need the number of people in Pima County. So Pima County says that there are 1 million people there. So we have some extra information about the population of Tucson, which is not helpful. So 1 million people, and then divided by the square miles, so that's the area. And then what you get here is about, you can round it, it says round it to the nearest whole number, so that is 109, and that is people per square mile. Okay, for this one, this is that relationship that with 45, 45, 90 triangles, they have a really special relationship. When you have the two sides, isosceles, that are the same there, these two sides, whenever you want to try to find the hypotenuse, you just have to multiply by radical 2 every time. So super easy to solve for x. This side is the same as this side, so x has to equal 8. And then if you want to find the hypotenuse, it's just 8 and then times radical 2. So 8 radical 2. So pretty quick. Okay, this one we're trying to figure out how high it's going up right here. So that would just be the Pythagorean theorem. So we would go 5 squared plus, and this would be the x, so 5 squared plus x squared equals the hypotenuse squared, so that would be 15 squared. So we have 25 plus x squared equals 225, x squared equals 200. So then we'd have to take the square root of both sides. So x is the square root of 200, which is about, it's close to 14, it's 14.1. So let's see, it says about how high is it? So 14 is definitely the closest. Okay, this is a little trig, so we can find the angle measures, or I'm sorry, the side lengths. So let's try to find this one. So if you have this angle measure, it looks like you have opposite, and then you're trying to find the adjacent. So that's a tangent relationship. So that's tangent of 57 is equal to opposite, that's 15 over the adjacent. This is the one that I do kind of a two-step. So I multiply by x first. So that would be x tangent 57 is equal to 15. And then I divide by tangent 57 to solve for x. So x is approximately, whenever we get there, 15 divided by tangent of 57. I can grab my calculator or look at something. So 9.7. Okay, then the other one is the y, so we can use our 57 again, and we can use the 15, except this time we have opposite, and this is the hypotenuse. So we're going to use sine for this. So we're going to do sine of 57 is equal to opposite over hypotenuse. Again, a two-step. So multiply by y first equals 15, and then divide by sine of 57. So when you do that to both sides, it would be y equals 15 over sine of 57. I'm okay with any shortcuts you like to do on this. I'm just showing all the work. So y is about something, 17.9. Okay, so this one we want to complete the congruence. So it says these two, are they pentagons? 1, 2, 3. Yeah, 2 pentagons are similar. That's a symbol for similar. So angle GFD is congruent. So angles are congruent when polygons are similar. So GFD, so this angle would be congruent to this angle. So that would be angle AED. And then the next statement is kind of comparing corresponding sides. So FD, that's this side, over the ED, the bigger length. That would be equal to GH, and then you could compare it with this side. So then we just say AB, again, corresponding sides. Okay, so 2 little problems here. These are just little Pythagorean theorem problems. So first, let me do it this way. Let me make, bug about it. All right, I'll do this first one here. So AB is 8, let me label, and BC is 6. Oh, well, this one's a special triangle, special Pythagorean triple, but we'll just show the work. So we're gonna go 8 squared plus 6 squared is equal to AC squared. So 64 plus 36, AC squared. AC squared is equal to 100. Take the square root. AC has to be 10. Okay, then you can do another triangle, and let's say this time the AC, that's that bottom part, is 6. And let's say the AB is 4, and then you're trying to figure out what this is, the BC. So I'm going to label it X, because I think some of you guys like that better if we just labeled X. So X is equal to BC, okay? So we're going to do 4 squared plus X squared is equal to 6 squared. So 16 plus X squared is 36. X squared, we're going to subtract the 16, so that would be 20. So good answer, square root of X is square root of 20. If you know how to, it says exact answer. So square root of 20 is an exact answer. You can also simplify the radical, so I'm not going to go into totally simplifying the radical right now, but it's 2 square root of 5, and that is BC. So remember I labeled the X as BC, so that's your BC. So BC, okay? Okay, this is like a triangle proportionality theorem. So really simple. You just you can put 4 over x is equal to 6 over 5, and then cross multiply. So 6x equals 20. X equals 20 over 6, which you can reduce, and that's 10 over 3. Then over here, same thing. You can do 8 over 10 is the same thing as 6 over x, cross multiply. 8x equals 60, x equals 60 over 8, and then you can reduce that, and they have a bunch of 4's in common, so you could do 15 over 2. Okay, this one's a bit of a process, so I'm going to go ahead and just I'm going to go ahead and plot the points. So negative 4, 1, 2, 3, 4, 1, 2, 3, 4. Okay, like about right there. So that's A, that's negative 4, negative 7, and then B is 6, 3, 1, 2, 3, 4, 5, 6, 3. Like about right there. Okay. All right, the segment that connects those looks like that. And what you have to figure out is we're trying to figure out where we would be if we divide the segment into a 3-to-2 ratio. So we're basically going 3 parts to this point and then 2 more parts. So what I usually do is figure out the fraction of the distance that it is. So it's going to be 3 over, and then you always just add those 2 together. 3 plus 2, that's the number that goes on the bottom. So we need to figure out 3/5 of the distance. 3/5 of the distance, okay, from A to B. So going from A to point B. So what I do is I do the change in y, and that means the part you're going up. The rise is what that is. That's rise. And then change in x, that's the run. Okay, so change in y, the way you figure that out is you take the y coordinates. So if you're going from A to B, you have to subtract the y coordinates. So you take your 3 and you subtract your -7. So 3 minus a -7, and that gives you 10. And then you have to do the same thing with the x's. You have to figure out you have to subtract the x's. So you're going to do 6 minus a -4. And this one also turns out to be a +10. So that's the total. This is the total rise. The y's are the total rise, and then the 10. Then the bottom 10 is the total run. Okay, but we want to figure out 3/5 of that distance. So we're going to do 3/5 of 10, and that's going to be the 5 can cancel with the 10, and so that's, or you can just use your calculator. So that's going to be 6, and what that is that's the rise, and that's the change of x. And then we do the same thing with the other one. We do 3/5, and that's 10, and of course that's 6 as well. So that's the run. So to figure out your new coordinates, the point that we're looking for, point R, is going to be equal to whatever the P was starting with, so, or whatever the A was starting with. So it started with -4 plus, we have to make the adjustment, and then it was -7 plus we make the adjustment. So it was -4, and then remember the run is the x. I sort of ran out of room, so I didn't write this the way I normally do, but the run is the x, and the rise is the y. So the run deals with the x first here, so we add 6, and then the rise deals with the y coordinate, so we add 6 to that as well. So the new point here we're looking for is 2, -1, and that's right here, and that means that point right there has, you go 3 parts, it has 3 parts on this side of the segment to 2 parts, so it's a comparison of 3 to 2, and it's 3/5 of the distance. Alright, these are trying to figure out which similarity postulate makes these similar. So the first one we have the 2 sides. If you compare the sides, you do 14 over 49, that's 2/7. And then if you compare the other sides, it's 8 over 28, and that's also 2/7. So they are proportional. They have the same ratio, the comparison of the sides. And then we also have vertical angles here. So that means this first one, they would be similar by the side angle side similarity. Okay, and that would mean, you have 2 sides that are proportional, and then you have the angle that's included that's congruent. Okay, then for this one, you have this angle is congruent to this angle because they're corresponding angles because of the parallel lines. And so then same with these angles. And then this angle, both triangles actually share because they share that same angle. This triangle right here, and then the bigger one, they have that same angle. So this one has all the angles in common. All the angles are congruent, but we just have angle similarity. And this is a little symbol for similarity. Kind of a little squiggly like I showed before. And then this one, this is 52, that's 52, they're vertical angles. and we know all triangles are 180, so you can find this missing angle, and it turns out to be 65, and then we're thrilled because now we have, you know, plenty of angles here, they're all congruent. So this one also is angle-angle similarity. Okay, we can try to figure out what the new coordinates are after they have a dilation. So the new coordinates, really all we have to do is just multiply the coordinates by 1/2. So right now the coordinates are, let's see, so right now B is -4, -1, and then if we want to figure out what the new coordinates are, that would be B prime, and we just multiply them by 1/2. So if we do that, multiply the -4 by 1/2, and so you would get, what would that be? So -2, and then if you multiply the -1 by 1/2, that would be -1/2. So those are your new coordinates. And then for the A, right now it's 4, 1, and that would be A prime if we, you know, multiply by the scale factor. So that would be 2 and then 1/2. So these are the new coordinates after the dilation. Okay, this problem utilizes the right triangle theorems. We have 3 of these right triangle theorems. So this is the one that's sort of on the right side. So what I do is we take this and put it over this. So we have 14 over x is equal to x. So let me back up. So this length on the right over this length is equal to this length over the whole thing. So 14 over x is equal to x over the whole length of the triangle, the whole hypotenuse there, so that's 20. And then we just cross multiply and solve for x. So x squared equals 14 times 20, what does that? 280, and then take the square root. So x is the square root of 280, and you can simplify that, so you can pull out a perfect square of 4, so that would come out as a 2, and there would be 70 left over, or exact answer. So really this is an exact answer. Hopefully we're not simplifying radicals much or at all. Alright, 21. You can use a few points on this one. So this one's supposed to be -8, 0. This one's supposed to be -4, 0. So, and then you do that with each of the 3 points. And you can tell the comparison there if you go from -8, and you can tell the dotted one is, you know, it's been dilated and it's been cut in half. So, and you'd have to do that for all 3 coordinates, but I'm starting to get tired and lazy, so I'm going to be efficient. So, let's see, scale factor, so you can kind of tell that the scale factor is going to be 1/2. So the rule goes xy, you know, turns into 1/2 x and 1/2 y, and so you can tell the scale factor is 1/2 because you're having to multiply by 1/2 to get the new coordinates. Alright, so we have a flag, so the Australian flag. It's supposed to be 8 by 17, so it tells you those dimensions. So 8, of course, would be the width, and 17 would be the ratio of the length. So 8 to 17 is the ratio. So then if the flag has a width of 30, then this would be 30 inches, and then we could figure out the length. So we'd be like, okay, what's the length? X. So we could say a couple ways to do it. We could compare the corresponding sides. So we could say 8 compares to 30 as 17 compares to x. So then we can cross multiply and solve. So we have 8x equals 510, and so x equals 63.75, and that is inches. So that's how long the flag should be, if it abides by that same ratio, so that it's similar, so it's the correct ratio. Okay. Volume of a sphere, so the formula we're going to use for this one, it's 4/3 pi r cubed. So it's going to be 4/3 pi, and then it's going to be 6, and we're going to cube it. And if it says to write it in terms of pi, that means we're going to multiply all the numbers together, and we're going to just leave the pi in the answer. So this one will be 288, and then we'll just include the pi. Surface area of a prism. So surface area is equal to the perimeter of the base times the height plus 2 times the area of the base. So let's figure out the perimeter. So the perimeter is that bottom part there, the perimeter of the base. So we just add up all the sides. So we got 5 plus 5 plus 16 plus 16. And so the perimeter of the base there would be 42. And then let's go ahead and figure out the area of the base. So the area of the base would be 16 times 5, which would be 80. And so let's go ahead and figure out the surface area now. So the perimeter of the base is 42 times the height. So you can see the height here is 15 plus, excuse me, 2 times the area of the base, which is 80. And then we just do the math here. So this total turns out to be 790, and that is square units because it's area. Okay, this one is a triangular prism, and so this side is 10. You can tell it's right here, it's listed. So we're going to let's figure out the perimeter of the base. So we add them up, it's a triangle, so we add them up, it's going to be 10 plus 6 plus 8, so that's going to be 24. And then let's find the area of the base. So again, make a note that B is the area of the base. So it depends what it is. So if it's a triangle, this one is, it's 1/2 base times height. So 1/2 times 6 times 8. So that's, what is that, 48 divided by 2, so 24. Alright, so now we're going to use the formula. So the formula is the same as the other one there. So it's the perimeter of the base times the height plus 2 times the area of the base. So the perimeter of the base we figured out is 24. The height is given right there. It's 4. So that's 4, and then plus 2 times the area of the base, which we found out was 24. So multiply those together, figure it all out, you get 144, and that is kilometers squared, square kilometers, okay? Okay, surface area of the cylinder. So surface area is really the perimeter of the base times the height. Well, the perimeter of the base is a circle, so perimeter is 2 pi r. Remember, perimeter is the same thing as circumference. So 2 pi r times the height, and then plus the area of the two bases, the top and the bottom, which are circles. So it's 2 times pi r squared. So we have 2 times pi, looks like the radius is not given, diameter is given, so we'll make that radius 7. The height is 8, plus 2 pi. Radius is 7, so we're going to say 7 squared. So we got 56 times 2. Well, that whole thing turns out to be 210. So 210 pi when you put those two together. And then that's about 659.7. And that's kilometers squared. Again, that's area, so square units. Okay, the measure of angle BAC, let's see. So this is 86, central angle is the same as the arc measure. This angle, this forms a straight line, so that's 180. So this one would have to be 94. So just do 180 minus 86, get 94. And let's see. So this is a radius, so they're the same. So that means these two angle measures are the same, so they're x and x. So what you can do is you can just take 180 minus 94. So do 180 minus 94, figure out what that is. What is that? 180 minus 94 is 86. And then you can just divide by 2. And you get 43. So that means that angle BAC, where is that one? Sorry. Oh, I didn't find that one yet. So ABO is what I was looking for here. So ABO, that one there, is going to be 43. So angle ABO is equal to 43 degrees. And then this angle here, this is also 43 degrees. What am I saying? So this one is inscribed. You can see this arc measure is 86, so we could have gotten the 43 that way. That would have been just as quick. So 43 degrees, they both are. So let's see, angle BAC is also 43 degrees. All right, what's the measure of arc, yada, 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 yada. Let's see what we got here. So the measure of arc BY is 49. Okay, this is half the circle, so if that's 49, we could just do 180 minus the 49 to figure out what this arc is. So that would be 131, and then this YAC here is whenever the vertex is on the circle, it's 1/2 of the arc measure it intercepts. So what's 1/2 of 131? That is 65.5. Okay, find the value of x. All right, so we got, from this angle measure, we have, that's right next to it, so it's adjacent. And this is the hypotenuse because it's straight across from the 90-degree angle. So which one does adjacent over hypotenuse? That's cosine. So cosine of x degrees is equal to 5/8. And then to solve for x, you have to do the inverse cosine. So we do inverse cosine 5/8. Make sure it's in degree mode. And you get about, we're rounding the nearest tenth. So that is something, where the heck is that? Okay, so that's 51.3 degrees. 29. Okay, this one had a little mistake, so I'm going to kind of fix it. So this one, let's just pretend like this base is a perfect square. So this is a square pyramid, because the one on your final will be like that. It'll be a square base. So if it is, then we can use this nice formula. So and see what we got here. So let's find the perimeter of the base. So we're going to do perimeter. We know it's a square now. So we're going to do 14 plus 14 plus 14. because I'm doing it the long way. Okay, so that is 56, right? And then we're also going to need the area of the base. So the area of the base is just a square, so it's 14 times 14. So that's 196. Okay, the full formula for a surface area of a pyramid, it goes like this. It is 1/2 times the perimeter of the base times the slant height plus that bottom there, that area of the base. So let's plug it all in here. So we got 1/2, we figured out the perimeter of the base is 56. The slant height was given right here, 24. And then plus the area of the base, which is just that square base, which is 196. And now I need to multiply this together. So let's do 1/2 times 56 times 24 plus 196. I got 868. That's 868. Okay, that would be square units. We don't have any units, so I'm not going to worry about it. Alright, let's see what we got here. So if we take, okay. So we're going to find first we find the area of the base by squaring 3 and multiplying by pi. So you square 3, you multiply by pi, then we multiply that by a product of 8. So this is looking pretty similar to the volume of a cone. I'm sorry, not the volume, a volume of a cylinder. So if you do pi r squared times the height, that would work. So the area of the base, again, that's coming from it's a circle, cylinder. So area of the base, and then times, if you multiply that by 8, that would be the height. So this would be C. It's the volume of the cylinder with the radius of 3 and a height of 8. Okay, we want to try to figure out the surface area of a cone. So we're going to use the formula. So surface area equals pi r L plus pi r squared. So pi, the radius is given, so that's easy peasy. Slant height 30. The radius is 13. So we just plug all that in, wham bam. We get 559 pi. Now you probably got, for this one, actually let me back up one sec. So we're going to get 390 pi plus 169 pi, because they're like, well, they both have a pi. So that's why you're just able to add those numbers together. Okay, kind of like, think of them as kind of like terms. 390, it's like 390x plus 169x, because of the same amount there. So you can do that. And that's units squared too. Equally. Okay, there weren't any units given on that one. Okay, surface area of a sphere. Surface area of a sphere. The formula is 4 pi r squared. So we got 4 pi, radius 8 squared. That is 256 times pi, which is about 804.2 to the nearest tenth. We want to follow directions. That's inches squared, square inches, okay? All right, a little bit of problem solving, tiny bit. So area, we know area of a circle is pi r squared. The area is given, that's 289 pi, so that's the left-hand side of the equation, is equal to pi r squared. We can solve for the radius, and then we can just double it to get the diameter. So let's solve for the radius. So let's divide by pi. We're going to have r squared, that's going to cancel, that'll be 289. Fortunately, we can take the square root R is 17. The diameter is twice the radius, so the diameter is 34. A walk-in closet, it's like a rectangular prism, so it'll have that same formula. It says the footprint of the closet has an area of 40. So if you think of, the prism like this, and I can't draw one at all, but the base is 40, so we already know the area of the whole base. All we have to do is just multiply by the last dimension, the third dimension, which is 8. So we're gonna do volume equals, it's always the area of the base times the height, and again the area of the base is given to us, so that's 40, and then times that third dimension, which is 8, so this is going to be 320, and because it's volume, that's cubic feet. And of course if you include your units here, if you put your feet squared here and you put your feet there, you can see that you've got 3 of the feet, so cubic feet. Right triangle, so we can draw it if we want to. So it has a side length of 5. It's missing this other side, so if we want to use, we could use a squared plus b squared equals c squared. So it doesn't matter which one is a and b, but we're looking for b or a, one of them. And then the hypotenuse is 13, so b squared plus 5 squared is 13 squared. B squared plus 25 is 169. B squared equals 144. So take the square root. B is 12. All right, mailbox, kind of a combination like we did in class here. It's a combination of if you think of a prism, the bottom part, and then we got the cylinder. So I'll put the cylinder kind of in red. It's half a cylinder actually. And then the prism is blue. Okay. So let's see. So let's do the prism. All right. So prism formula. So we're gonna do the volume. And what's the volume of a prism? So it's the area of the base times the height. So the area of the base times the height, or just length, width, height. So it's gonna be area of the base, so 6 times 13, and then the height is 3. So let's multiply all those together. What do we got? 2, should have 234. Okay, then the red part, that is a half a cylinder. So let's do the volume of half a cylinder. Alright, so that would be, it would normally be pi r squared times the height, so it's going to be 1/2 of that. Pi r, the r here is, see, this whole thing is 6, this is the diameter, 6, so that means the radius will just be that much, so it'd be 3. So that's going to be pi 3 squared, and the height of the cylinder, it's like a cylinder turned sideways, so the height is 13. Alright, so what do I got so far? I got, what do I have? Oh, looks like I did. Okay, so this part, if you multiply 3 by the pi, you should get about 183.8. So we're just doing an estimate on this. So we're going to add the 234 plus the 183.8. So we're going to get about, so the volume of the whole mailbox is about 417.8, and that's cubic inches. Okay, find the value of x and y. So a lot of triangle trig. So if you want to find x, then you see that's opposite, and then this is adjacent. So we're going to do, we have two problems here. So we're going to do tangent of 33 is equal to x over 27. So hey, this is a one-stepper. So we multiply by 27 on both sides. So 27 times tangent 33. And so x is approximately, rounding to the nearest tenth. Oh, I thought we, oh yeah, we do have two problems. All right, so we have 27 times tangent of 33 is about 17.5. Okay, then let's solve for y. So if we want to solve for y from that angle, we have the adjacent, and then we have hypotenuse, because it's across from the 90-degree angle. So adjacent over hypotenuse, that's a cosine relationship. So cosine of 33 is equal to 27 over y, excuse me. This is a two-stepper, so you multiply by y first, and then divide by cosine of 33. I'm gonna, because I've done several of those now, so now I'm gonna skip that step. So y equals 27 over cosine of 33. So y is about 32.2 degrees. No, what am I saying? It's not degrees. It's just 32.2. Okay, sorry, I was getting a little tired. All right, 38. Okay, so draw a picture. So you got, what do we got? 32-foot long cable. 32-foot long cable. It forms 52 degrees with the ground. Question is, and it's going up a pole. This is the pole. We want to try to figure out the height of the pole. So let's say we want this to be x. So then we see we have opposite, and then we have hypotenuse that we're dealing with. So this is a good sine relationship. So we're going to say sine of 52 is equal to opposite, which is x over 32. And so we're going to multiply by 32. So it would be 32 times sine of 52. And that would be, x is about, what is that? It's about 25.2. And that is feet. This one actually has, doesn't have, yep, feet. All right, area of a sector. So area of a sector is going to be formula. We're going to do the degree measure, just like of the central angle. It's also the same as the arc measure. So we're going to do, always we're going to take that and we're going to divide it by 360. And then we're going to multiply that by the area of the circle. It's a fraction of the area of the circle. So it's pi times 11 squared. And then if it says to the nearest tenth, we can just multiply it all together to get the answer. So this one turns out to be 121 over 8 pi if you just did the number part. But again, it says nearest tenth, so you can just multiply all that together. 47.5, and that's going to be its area, so it's square centimeters. Okay, 40, which one's kind of describing how we're getting to the pyramid versus the prism? And the one that does the best job with it is this. So we start off with the volume of a prism, and then it's only 1/3 of that. And so you know, that does the best job of kind of explaining in words, you know, how a pyramid is kind of less than a pyramid's, you know, 1/3 less than the volume of a prism. That's what it's kind of saying. It's not really a derivation, but it's kind of describing it. All right, let's see, what are we doing? So for this one, we're going to go ahead and use that formula. Oh, no, we're not. JK. Did I skip one? Oh, my. I think I did. Oh, no. I missed one. Oh, well. Maybe it'll show up somewhere. All right, so 42. Let's see, angle BAC. All right, so this is a straight line, so that's 66. So this one is 114, and that means this angle, this arc measure is 114, and this is an inscribed angle, so we can say that that's 1/2 of 114. Oh, I already found the measure of BC, so that's 114, and then angle BAC is, the measure of angle BAC is 57. 57. It's always 1/2. So inscribed angles are 1/2 of the arc measure that they intercept. Okay, so we have a pole. Casts a shadow of 27 feet. A pole, let's see, 126-foot pole. Casts a shadow of 27 feet. Doesn't look like 27 feet, looks like a lot more. And the question is, find the angle of elevation. So find that angle right there. It's on the way up. So it's always the angle that's made with the horizontal. So angle of elevation, so we can see the sides involved here are opposite and adjacent. So that's a tangent. So tangent of, let's just call this, a lot of times with angles we call them theta, but for this class I'll say x. So tangent x degrees is equal to 126 over 27. X degrees equals, we're going to have to do inverse tangent. So inverse tangent 126 over 27. Let's see what we get here. So we should get about, x is approximately 77.9. Okay, I'm alright with that. Okay, this one, how far, yada yada. So just Pythagorean theorem. So we got x squared plus 60.5 squared is equal to 90 squared. So do the math here. We got x squared plus, all right, what's 60.5 squared? 366.25. Why did I write all this out? 90 squared, 8100. And then we can subtract. So 8100 minus 3660.25 is 4439.75, and then we can take the square root. So x is about, what is that? Square root of 4439.75, about 66.63. It says how far, so we just look for the best answer there. So it looks like A, feet. All right, almost home. Speaking of baseball, rounding third base, kinda. All right, so find the length of darkened arc. So arc length, really similar to area of a sector. So arc length is going to be the arc measure or central angle measure over 360. It's the fraction of the circle times the circumference, because it's not the whole circumference, it's a fraction of the circumference. So this one says leave it in terms of pi, so we multiply the numbers together, and when you do that you should get 6, and then you just include the pi, so 6 pi. Okay, 46, special triangles, I usually compare it to this. So 30, 60, 90, 30 is the x, 60 degree side, the one across from 60 degrees is x radical 3, and the hypotenuse is always twice as big as the 30 degree leg. So if you have 9 and you want to try to find the 30 degree leg, we know that it's 1/2. So you can just divide 9 by 2. So A is 9 over 2. And then if you want to find the B, you just have to take the 30 degree side, which now we know is 9 over 2, and then you can multiply it by radical 3 to get the 60 degree side. So we're just going to do 9 over 2 times radical 3. See me if you need a review on that. Okay, this is just establishing the ratio of the sides. So sine of A is opposite over hypotenuse, so that would be 4/5. Sine of C is opposite over hypotenuse, so that would be 3/5. Cosine of A, adjacent over hypotenuse, so that's 4/5. Cosine of C would be, oh, booger butt, I messed that one up. Cosine of A is right here, so cosine is 3/5. My brain is getting tired. Cosine of C is 4/5. And then tangent of A, that would be opposite over adjacent, so 4/3. And then tangent of C would be opposite over adjacent, so that would be 3/4. This is probably the longest video I ever made in my life. Okay, so EV is 10. This is a square. Okay, LV, this is a 45, 45, 90 triangle. So this is, we can just figure out, we can use the Pythagorean theorem, or you can just multiply by radical 2, because it's that special relationship again. So 10 radical 2. Area of a sector, we did one of those already, so that should be 110 divided by 360 times pi r squared. So pi 5 squared to the nearest tenth this time. So we just multiply it all together and get a decimal. So it turns out to be something, something. What does it turn out to be? 24.0, and that is square meters. Okay, draw the net. You're basically unwrapping this baby. So this is the base, this is the base, kind of unwrapping it from there. So when you do unwrap it, you would have 3, so this would be the base, okay, at the bottom. And then you would have the sides, you could unwrap them that way. And then the other two, these triangles are kind of like the ends, and then these are like the sides. So you have 3 parallelograms, this triangular prism. It has 3 rectangular, 3 rectangles, yeah. All right, so that should be good. So that was easy and long. Good luck. Good good. Oh, I didn't need to have that on there. Oh my goodness gracious. Okay, gotta end this. I just want to say good luck. Ay, caramba. Oh well. Good luck. I can't even spell luck anymore. Okay, good luck.